Hi guys, today no design, no high voltage, just a teardown. 1 year ago I think I bought this GPS simulator from Spirent. It's a GSS6100. It's a single GNSS, GPS only and S-Bus. When I bought it, it was sold on eBay for parts only, with a description, not doing nothing, not powering up. This encouraged me to say, okay, if it doesn't power up, the possibility is higher that is a PSU problem, a power supply issue. It was cheap. The shipment was almost the cost of the appliance. To be honest, even more expensive. And as I thought it was the power supply unit, it was a blown fuse. And the fuse was blown because the primary bulk capacitor, high voltage capacitor, had a short. And every time you put a new fuse, it was blowing it. Then there were a couple other capacitors that were bulged, and that's it. All the rails are now perfect. It puts quite nice, as we can see later. This thing is quite a big beast, and you will see what the whole electronic, the whole RF goodness that is inside. So that's the front. You don't have too much. It's just the power and the health LED. When the health goes green, I assume the system thinks it's okay. You have an active, that means probably, I didn't test it, I couldn't test it yet, because I didn't have the software for it, but there is a solution, perhaps, you will see later, and an N connector for the RF output. Let's turn it around. Wing! You like my merry-go-round? I like that. Look at that. Anyway, calibration monitor, I don't know what it is. I have to check the documentation. This is the most important connector, because you can control this simulator in 3 ways. The standard way, through the USB, connected to the PC and using the SimChan, I think 1.0 software, that is working, or the drivers are working only at XP. That would mean you need a virtual machine, etc. And the GUI is, well, from the time that it is written. The second thing is you control it from here, completely from the via the RS-232. The GUI software does not do anything else, just and sends the command. This command that you can send through the serial port, you just send it with mouse clicks. That means that if somebody could write the software that sends the correct commands to it, and you will see it is very easy because there are not too many of these commands. This unit is fully controllable. The aux output, you have here pulse per second, etc. It is all written in the documentation. The documentation is available. When I got it, this was like that. It was a hole, so somebody poked it. Somebody tried to calibrate the 10 megahertz reference inside. It's an OCXO. We will see that later. Output level calibration, nothing have been done. Trigger, I don't know what that is. BNC for the external reference, 10 megahertz reference in, 10 megahertz reference out, and the GPIB, or IEEE 488. And that's the third option. You can control it. The commands to control this interface, this unit, are the same either through RS-232 or via the IEEE 488. It's quite a loud unit, you will hear it later. These things are flooding eBay at the moment, either for parts or working, but none of them is coming with the SimChan software. So from what I see, the only possibility is to use it through either the GPIB or even better through the RS-232. Okay, let's boot it up. Just a short peek about the boot. Absolute no thrills. When the health LED is lit, I assume that it works. So that's a boot up. This is the start sequence. It is very easy to control it. For example, I will send the command E10. It gives information about the appliance itself. And to be honest, the SimChan, or what's they call the software, it's just a no-thrills GUI of these commands. The generator can be fully controlled over the serial interface, and via the GPIB. The baud rate is 38400, 8 bits, no parity, and no handshake. This is what the boot sequence looks like. This is how it's connected, just a normal serial to USB controller with a very cheap prolific chipset. Again, baud rate 38400, 8 non-1, no handshake at all. And the next would be to control it via the host IEEE 488. So in reality, you don't need the USB port, but you will not get driver so, at least not for Windows 10. That means if somebody would write the software that could send these commands, the necessary commands, via the serial port or the GPIB, nobody needs a SimChan software anymore. Okay, now it's time to look what is inside. I already opened it from the above. Let's take a look what we'll see here. There are a few sandwiched PCBs. Okay, here you can see the OCXO. On the right side of that, you see the two trimmers, one for the OCXO, this one, and the other one for the calibration, the output calibration. Further, we see the complete in a metal box, screened, shielded RF part. This goes out to the SMA on the back. That should be connected to a SVR power meter for the calibration. And this goes directly to the output of the front. This is the power supply I repaired a couple of years ago. I do not have any footage from that time, but I have a few pictures that I will show you. The baseboard, I have some pictures of that too because I removed it. There are a lot of FPGAs. Let's see what else we can see here. Well, I cannot read it. Ah, yes. MPC 9774, whatever that is. EPM 3032A. Yeah, I will check them later what that is. I don't know what it is. Then we have a 9754. That's the AD 9754. It's a 14-bit, 125 mega samples D2A converter. Nice piece. That's the next one, the MPC 9774. That's a 1-to-14 PLL clock generator. Then we have the EPM 3032A. That's an PLD device. This thing is full of FPGAs and PLD devices. This is the other side, the bottom side of the device. I have some interesting parts. I don't know this one what it is. It's on an HCT, there's nothing, but this one is interesting. I don't know what that is exactly. Here, this board is the GPIB controller board, this one. Again, difficult to read. Okay. This seems to be the main processor board. It looks very nice. This is a part of the RF goodness. Again, I have some pictures that I will show you. I wanted to see which chip they use for the USB, but I can't find it yet. That's the next one, interesting chip. AD 9760, 10-bit high-speed D2A converter. Another interesting chip, but rather old chip, is the one from Siemens. It's a PMB 2306T. It's a PLL frequency synthesizer. Interesting chip. There are a lot of stuff. There's a lot really interesting stuff, and I'm sure that would be much more under the HIF shield, but I will not open it yet. This is the label of the HIF RF assembly. Seems it is common to the 4100, 4500 series of appliances. Again, an overview. Here are some higher resolution pictures. I will add these pictures to my community tab. I don't know if it will work, but I want to add it to the YouTube. This is from the time where I removed the power supply to repair it. Just an overview now. This is a little boring. And this is the one that I removed completely, so you can see everything, but I will upload these pictures. So that's for this rather fast teardown and the information that I have till now regarding this unit. If you have any more information about the SimChan software and how I could get it, or if there is an alternative software that controls this thing via the serial port or GPIB, please let me know. This is the first part of the test. The second part will be to do a little bit more with a serial port and to try to get something on the output with the help of a spectrum analyzer to see what's coming out. Okay, guys, if you like my videos, if you like what you see, please push the like button and subscribe to my channel. This will help me to be able to get some more of these things and show you more interesting stuff. Thanks guys for watching. Cheers.